Hi all, welcome to the video lecture series of Object-Oriented Programming. In this video lecture, we'll be discussing about the topic exceptions in Java. These are topics that we'll be discussing in this video lecture. First of all, we will see what are exceptions in Java, then we will see how to handle it. In dictionary, exceptions means an abnormal condition. But in Java, we define exceptions as an event that disrupts the normal flow of a program. So anything that disrupts the normal flow of a program in Java is said to be an exception. So the problem that arises during the execution of a program is said to be exceptions. As we all know, when any kind of problems arises during the execution time of a program will come to an end or it will terminate. So if we have some methods or if we have some way to handle those problems, we can prevent the termination of the program and the program can run smoothly. So that is what we are going to see in handling exception handlings. And there are many reasons by which the exceptions may come. For example, the data entered by the user may be invalid, or sometimes we are dealing with file operations and suppose a file that we are trying to open, it may be lost forever, so we cannot open the file. That is another problem. Or in between the communications, some kind of network mishap happened and it is not able to able to connect anymore. These are some of the examples of some exceptions or the problems that may arise when we execute a program, and all these problems are said to be exceptions. And the good news is Java provides us with a mechanism to handle all these runtime errors, and that mechanism is known as exception handling mechanism. So what's the advantage of this exception handling mechanism? The main advantage of this mechanism is it is possible to maintain the normal flow of the program even if some errors occurs, right? So consider an example. Suppose we have 10 statements in our program and an error occurred at line number 5. Okay, so all the remaining lines of code are correct. That is statement 1, 2, 3, 4 and 6, 7, 8, 9, 10. All of them are correct. But only one line is the error, or the error occurs only at one line. So if we can handle that error that occurred at line number 5 or statement 5, the remaining statements of the program can be executed without any problem. So that is a need of, or that is why Java provides us with the exception handling mechanism. There are different types of exceptions. We will see what are they. Exceptions are classified based on the reasons by which they occur. There are different reasons by which an exception may arise. They are, first one is user error. The input the user gives in for a program may be of undesired or unwanted type. That may lead to an exception. Second cause is by the programmer error. The statements that the program is right, that may lead to undesired situations. That is what we mean by programmer error. And third one is due to physical resources like memory, out of memory, or the files may be corrupted that we are trying to access. All these will lead to exceptions. So based on these three causes, we are dividing the exceptions into three categories. They are checked exception, unchecked exception and error. Now we will see each one of these three in detail. First of all, we will see what is a checked exception. Checked exceptions are those exceptions that are notified by the compiler at compile time. Therefore, these are also known as compile time exceptions. Examples for these kind of exceptions include, suppose we are trying to read a file and we have written some lines of code for opening a file, and when we compile it, suppose that file that we are trying to open does not exist, then we will get an exception known as file not found exception. So that is notified when we compile the program. So such exceptions that occurs during the compile time or that are notified by the compiler at the compilation time are known as compile time exceptions or checked exceptions. Why we are calling it as checked? Because the compiler can check whether such errors occurred, errors are there inside the program or not, and it is possible to find out these exceptions during the compile time. That is why it is known as checked exceptions. The second category of exceptions that we have discussed is known as unchecked exceptions. We have seen what is checked exception. So unchecked, from the name itself, it is just the opposite of checked exceptions. These are the errors that occurs at the running time of a program. These kind of errors will be ignored by the compiler at compilation time. Since these errors occurs at the running time of program, these are also known as runtime exceptions. And these exceptions includes programming bugs like logical errors. And one of the examples of, or one of the most commonly occurring unchecked exception is that of array index out of bounds exception. That is, suppose we have declared an array of size 4. We know that the index number starts from 0 and it will go up to 3, since there are only 4 elements or 5 elements. In the case of, if the size of the array is 5, the index number, the last index number will be 4. And if we try to access any element at index number 5, in such cases the exception that occurs will be array index out of bounds exception, because we have only index number up to 4. Since the size of the array is 5, the index numbers will be from 0 to 4. Even then, if we try to access an element index number 5, so such an index number does not exist. So we are trying to access an element that does not exist. So in that case, these errors will not be notified during the compilation time, because the syntax is correct. We are not doing anything wrong with the syntax, but logically it is not correct, because we are trying to access something that does not exist. So that will be notified only during the running time of the program. Such kind of exceptions are known as unchecked exceptions. They are also known as runtime exceptions. You can see one example mentioned here. The third category of exceptions is known as an error. An error is actually not an exception at all, but these are the problems that occurs beyond the control of the user or the programmer, that not even the programmer who typed the program can handle this. So when such kind of exceptions or error occurs, we typically ignore them, because it's not possible to handle them in any way. One kind of exception is, or one example for these kind of exceptions are the stack overflow. That is, when the memory is full, or when the stack is full, we cannot do anything to what we can say, free the space inside a stack, right? Such kind of errors are known as such kind of exceptions are known as errors. These kind of errors are also ignored at the compilation time. We won't be able to realize, or we won't be able to recognize these kind of errors when we compile the program. These things, or these kind of errors will be can be notified, can be realized only when we run the program. We said in the beginning that Java provides us with the exception handling mechanism, and that exception handling mechanism is through this try and catch blocks. Okay, not only try and catch blocks, there are 5 keywords altogether we have to learn, but these 2 blocks are the most important ones. So we will see what are try and catch blocks right now. There are certain keywords that we have to learn in order to learn the Java exception handling mechanism. Altogether there are 5 keywords that you have to consider. They are try, catch, findly, throw and throws. We will study each one of them in detail, but in general, try is the block in which we have to write those lines of code from which we expect an exception or an error. We call the first 3, that is try, catch and findly. All these 3 are known as block. Block means we'll have to open a pair of curly brackets and we have to write the lines of code inside it. So try is a block of code, catch is also a block of code, and findly is also a block of code. Okay, and try block cannot stand alone. If we are writing the try block, it must be followed by a catch block or a findly block, or both. It cannot stand alone. So try is a block inside which we will be writing those lines of code from which we expect an exception. Catch block must be followed by a try block. It cannot stand alone, and there can be multiple catch block for a single try block. And catch block, as the name indicates, it is used to catch the exception that occurs inside the try block. So If any exception occurs in any of the line of code inside the try block, that exception will be caught by the catch block. So all the lines of code that we have to use or that we need to perform if an exception occurs, that lines of code must be written inside the catch block, and we have to specifically say the type of exception we are going to catch. So for each catch block we have to specify the type of exception that catch block is going to handle. We will see in the upcoming slides an example for this, then it will be more clear. Then finally block is the block of code that must be executed even if the exception occurred or even if it is not occurred. That means even if the exception is handled or not, the lines of code inside the finally block will be executed. That you have to keep in mind. So all those lines of code, like closing a file, closing a database connection, closing a scanner class connection, all those lines of code that needs to be executed even if an exception occurred or not must be written inside the finally block. Then throw block is used to manually throw an exception. That is, if the programmer who is writing the program needs to raise an exception if the client tries to do something, then they can use the throw keyword. And throws keyword is used with the method signature. This keyword is used to indicate that the method, there's a possibility that the method may throw an exception. So all those who are making use of the method must beware of that and must be ready to handle the exception that this method is going to throw. So in order to indicate that, we will be using the keyword throws, and it is used along with the method signature. We have explained Java try block just now, but again we will see some more details about try block. So try block is used to enclose the code that might throw an exception. The lines of code from which we expect an error or exception must be included inside the try block. Then it must be used within the method. Okay, it's not inside the class. I mean, it's not like just inside the class. We have to use the try block inside a method. Okay, and if an exception occurs at any particular statement inside the try block, then all the lines of code below that statement will not be executed. So as I mentioned, if I have included say 10 statements inside try block, if the third statement inside the try block generated an exception, then all the remaining lines of code from line number 4 to 10 will not get executed. So it is necessary, or it is recommended to write only those lines of code that may arise, or that may what we can say, that may cause an exception inside the try block. Not like we have to write the entire program inside the try block. Okay, only those lines of code from which we expect an error must be written inside the try block, not the entire program. And Java try block must be followed by either a catch block or a finally block, or both. Okay, it must be followed by a catch block or a finally block, or both. Okay, try block cannot stand alone. So the syntax of try catch block, that is try, as you can see here, word try, then we are opening and closing a pair of curly brackets, then the catch block. For catch block we have mentioned the exception that we are trying to catch here, that we'll see when we explain about the catch block. Here also we have to use a pair of curly brackets because it is also a block of code. Similarly, try block can also be followed by a finally block like this. So in this example, in this syntax there is no catch block, it is the finally block followed by the try block. In this syntax there is no finally block, it is the catch block followed by try block. Okay, so try block cannot stand alone, there must be either a catch block or a finally block soon after the try block. Next is the catch block. So this catch block is used to handle the exceptions by declaring the type of exception within the parameter. As we have seen in the previous slide in the try catch syntax, when we wrote the catch block, there was a parameter, and that parameter indicates the type of exception that catch block is trying to catch or handle. Okay, so for each catch block that we write, there will be an exception name that is given as the parameter. That means that catch block is trying to handle the exception of that type. Okay, so the parameter that give for the catch block must be either the parent class exception or any generated exception type. That means there are different exceptions that can occur, like arithmetic exception. When we try to divide a number by 0, that will raise an arithmetic exception. When we try to access an array element that is not there or that is out of the index, then array index out of bounds exception. So for each exception that arises, there is a category, there is a class. All exceptions that may occur in a Java program, okay, are child classes of the parent class named exception. So when we give an exception name as parameter to a catch block, it must be either the parent class exception or any child class of the class exception. That is what I mean by the sentence. Then the good approach is to declare the generated type of exception. That means we know that we expect a particular type of exception, right? When we try the try block, we are writing some lines of code inside the try block, and from those lines of code we are expecting some kind of exception. Suppose we have written the lines of code for performing some mathematical operations, then we are thinking about, we are expecting an arithmetic exception, an exception that deals with arithmetic or mathematics, that is going to happen. So we must give, or we must write a catch block that is capable of handling arithmetic exception. That is what we mean by this. That is, a good approach is to declare the generator type of exception, and a catch block must be declared only after a try block. A catch block cannot stand alone, and also there can be multiple catch block for a single try block. That means a single try block followed by a number of catch block that is possible. Okay, suppose we need to handle arithmetic exception, we can write one catch block of handling arithmetic exception. Suppose we need to handle array index out of bounds exception, then we can write another catch block. Without writing a new try block, for the same try block we can write multiple catch block. Now we will see an example of exception handling by try and catch block. So see this program, we have written a class, we have started main method, and we are writing int data equal 50 by 0. That is, we are trying to divide a number by 0. Is that possible? That is not possible. So when we execute this line of code, it will generate an error or exception. So when we try to execute this program, we will get this error: exception in thread main java.lang.arithmetic exception and its division by 0. So this is an exception that occurred at this line. Okay, so there is no try catch block in this example, in this program. So in this case the program will terminate. Okay, now we are going to write the same program by using try and catch block. Okay, so we have written another class, we have written the same main method. See, we are writing this line of code inside the try block. Definitely we know that this line is going to give an error. This is only an example. What we mean is, those lines of code from which we expect an error must be written inside the try block like this, where try, open a pair of curly brackets, write all those lines of code inside from which we expect an error inside the try block. And see, suppose any lines of code inside this try block generated an error, we need to handle it. For that we need to write the catch block soon after the catch block, soon after the try block. So here we have written arithmetic expression E. That means we are expecting a kind of arithmetic exception in these lines of code that we have written inside the try block. So we can write catch arithmetic exception. So in that case, if an arithmetic exception occurs in any of the lines of code written inside the try block, it will be handled by this catch block. If it is not an arithmetic exception, then this catch block will not handle it, because we have written the catch block only to handle the arithmetic exception. Okay, suppose the lines of code inside the try block generated any other exception other than arithmetic exception, then in that case we have not written that corresponding catch block. In this example we have written only one catch block which is used to catch the arithmetic exception. So only the arithmetic exception will be caught here. So this means we are writing this catch block is written to catch the arithmetic exception. So whenever we write the catch block, we have to mention the exception that we are trying to handle, and that exception must be given as a parameter here. So in this case, this catch block will handle the exception. Handle the exception means we can write the lines of code. If such an exception occurs, what we have to do, all those lines of code can be written inside the catch block. Okay, all those lines of code that we need to execute when any exception occur, that can be written inside the catch block. So if an error occurred and if we need to modify it, if we need to change it, then we can write all those lines of code that we have to do inside this catch block. Okay, so only if that exception occurred inside the try block, then only this catch block will get executed. Okay, so also if there are 5 lines of code inside the try block and if the second line causes the exception, all the remaining 3 lines of code will not get executed inside the try block. From the line at which this exception occurred, the control will be forwarded to the catch block, and the catch block will check whether the exception that it is expecting has occurred inside the try block. If the exception that we are given as a parameter here is the same exception that occurs inside the try block, then all the lines of code inside the catch block will be executed. Okay, and once all the lines of code inside the catch block is executed, the remaining lines of code outside the catch block will be executed. So in this case, if we try to execute this program, we will get the output like this. There was an exception, so it was division by 0. We got this line of code because we have printed it here. Here E is the object of arithmetic exception. So we got this line of code here just because we printed this E. Okay, and we handled the exception and we got the remaining line of code. The rest of code, this line also got executed. The rest of code will get the output here. This line got executed because we have written the catch block and we have handled the exception. Okay, in this example, this line of code was not executed because this line caused the error and we have not handled it. But that is not the case here. We have handled the exception, and since we have handled it, the remaining lines of code will also get executed. So we'll get the. We shall conclude now. In this video lecture, we have seen what an exception is, what are the different types of exceptions, what do we mean by exception handling in Java, the different keywords that we have to deal with when we have to handle an exception, then what do you mean by the try and catch block in exception handling. We also saw some of the examples. In the upcoming videos, we will see what we mean by throw and throws, and also the finally block, and also how to use multiple catch block for a single try block. That is all in this video lecture. Thank you so much.